All right, these problems are called consecutive integer problems. And let's first look at some vocabulary. Consecutive integers are, first let's start with consecutive. Consecutive means one right after the other. In numbers, they're numbers that go from smallest to largest, and there are no gaps between numbers. Integers are numbers with no fractional parts. Now, our integers may be positive or negative, but there are no fractional parts here. So I'm not going to have negative 1.5 or 7.5. It's always going to be an integer. You can see the examples we have here. Something as simple as 1, 2, 3, 4, 5. That would represent 5 consecutive integers. So remember that with a consecutive integer, each number is exactly one more than the one that came before it, except for different cases that we'll look at. Let's look at an example problem of consecutive integers. It says to find 3 consecutive integers whose sum is 126. Well, the first integer is always x. We don't know what it is. And in algebra, when we don't know what it is, it's x. So the first integer is x. Now, what integer comes right after x? Well, since we don't know x, how are we supposed to know? And we represent it as x plus 1. So the first one's x, the second one's x plus 1, and you guessed it, the third number is x plus 2 because it's 2 more than the original. So we are looking at 3 consecutive integers whose sum is 126. So look, we're going to add all of these together. So I add x, x plus 1, x plus 2, and I get 26. I regroup these, I add them, and I solve my equation, and I get that x is equal to 41. Well, if x is 41, guess what x plus 1 is? You guessed it, 42, and then 43. And just to be sure, when I add these up, I do indeed get 126. It's always a really good idea at the last minute to go and check and make sure you get the answer that you should get based on the numbers you find out. Now, sometimes we will get something called consecutive even integers. Now, this is interesting. Now, consecutive even integers are 2, 4, 6, and 8. That's one example. But notice that each number is not exactly one more than the one before it. It's 2 more. So each time I'm adding 2 to the previous number to get the one that's right after it. Now, for that reason, I don't do x plus 1, x plus 2, x plus 3, x plus 4. I add 2 more each time. So when you're doing these kinds of problems, it's really important that you keep track of what's the first one, what's the second, what's the third one. So in this case, I want the sum of 3 consecutive even integers is 48. 3 of them. So here's my first one, x. The second one's x plus 2, and then x plus 4. And then I do the math where I combine my like terms. I solve for x and get that x is 14. Well, if x is 14, the second one must be 16, the third one 18. So those are my 3 consecutive even integers. So of course, if I've got consecutive even integers, I have consecutive odd integers. But here is what is counterintuitive about consecutive odd integers. Whereas with even integers, we added 2, 4, 6, and 8 as we go forward. Well, guess what? We do that same thing with consecutive odd integers, because each of these numbers is exactly 2 more than the one before it. So I may be going from 3 to 5, which are both odd, but to get there, I'm still, oh, rats. I hate it when that happens. Excuse me, y'all. Got to do this. I really hate it when that happens. I forget to click this. Pardon me. So even though they're odd, to get from one odd number to the next, I'm adding 2 each time, which is why the template that we use to keep in mind to do consecutive integer problems is the same for both even and odd consecutive integers. So in this case, I wanted to find 3 consecutive odd integers whose sum is negative 39. I set my problem up the same way. I combine like terms. I get that my x is negative 15. Well, what's the next consecutive odd number after negative 15? Negative 13, negative 11, negative 9, and so on. Okay, so that's negative odd integers. But wait, there's more, because this stuff can get really complicated. Listen to this problem. We want 3 consecutive odd integers such that the sum of the first one and the third one is 70. Well, wait a minute, that just got a little bit complicated. So when you start getting these convoluted consecutive integer problems, it's very important, I think, in the beginning that you give yourself some placeholders. So you see that I've done that here. What I always do when I get started is I give myself 3 blanks or 4 blanks, depending on how many numbers I have. And then in the blanks, I begin to number them. No matter what I'm doing, these are odd integers, so I know my first one's going to be x. I know my second one's going to be x plus 2, because it takes 2 to get to the next odd one, and then x plus 4. So I know that this is what my 3 numbers are. And then I go and read the problem, and it says I want 3 consecutive odd integers such that the sum of the first one and the third one. So guess what? I only need this one and that one. But sometimes if you don't write them out, and I mean pick up pencil up, write these down. Do not try to do consecutive integer problems in your head. You will crash and burn in the deserts of Arizona. So don't do that. So this is my first one. This is my third one. I add them to get 70. I rearrange combine like terms, solve for x, and I get that my first number is 33, my second is 35, and my third one is 37. So here we have some other problems here. I thought I might do one of these more difficult ones with you. It tells me to find 5 consecutive even integers if the sum of the first and fifth is 2 less than 3 times the fourth. Oh my word, that's a crazy problem. So I'm going to start off knowing that I've got 5 consecutive integers. 1, 2, 3, 4, 5. I know the first one is x. Because I want even integers, I know that the second one is x plus 2, x plus 4, x plus 6, and x plus 8. Those are my 5 consecutive even integers. Now it tells me that the sum of the first one and the fifth one, well, this is the first, the second, the third, the fourth, and the fifth. So I'm going to say x plus 8 is equal to 2 less than, I'm going to take 2 away from, 3 times the fourth one. The fourth one is x plus 6. So I'm going to say 3 times x plus 6. So you can see how absolutely complicated these problems can get. So you must write them down, and you must have some kind of organized fashion to keep all the different integers straight. In solving this one, I'm going to combine my like terms on this side. I'm going to distribute on this side. I'll end up with 3x plus 16. I'm going to bring this 2 over here. I've run out of room, so I'm coming up here. So the negative 2 goes here, so I end up with x on this side. because that goes over there. The 16 goes over there, so it's going to be negative 8. So my first number is negative 8. Make sure this is right. I'm going to really check my math here. So if my first term is negative 8, this is negative 6, negative 4, negative 2, and 0. So the sum of the first and the fifth, so negative 8 plus 0 is equal to 2 less than 3 times the fourth one. 3 times the fourth one, that's negative 12. And I'm going to say 2 less than 3 times the fourth. That's negative 14. And so I've done something wrong here. So I'm going to challenge you to figure out what I did wrong. I'm way into this video, don't want to remake it. So rather than me remake my video or redo this problem, you figure out what I did wrong. So we will see you in class and have a great day. Bye.